Hey, how's it going, everyone? Welcome to the stream. So, yeah, last week I was supposed to stream on Thursday, but I decided to not stream because I was feeling rather tired and just decided to take a break. So there's quite a bit to catch up on. Even though I wasn't on, I did get the chance to work on Vectrexy in between. So why don't we start by going through those changes. So basically, what we did on last stream was here, average PSG samples to improve quality of sound. Yes, if both tone and noise are disabled on channel, return center value. So then I have this here, which is remove period checks from generators, and I actually ended up reverting this later. So let me see here. I'll talk about that after. Model PSG channels into classes. Oh yes, we did this on stream actually. So that covers, yeah, all of July 17th, which was the last time I was on live. Now after that, I went ahead and we started this on stream. I had written this like plot data class. After the stream, I ended up kind of filling out way more ImGUI debug output to help me understand what's going on when we play audio, and I'll be showing you that when I demo the emulator soon. Then here I wrote this: effectively disable the tone generator when its period is 0. So this here is kind of interesting. Yeah, this is me basically trying to figure out why certain sounds, like certain things were not sounding right, like in Scramble, for example. And actually, there was this one homebrew ROM that I was listening to that really sounded quite awful. And it was the one that I started using as my, like, I gotta make this sound good. Because as it turns out, this guy, let me just bring up my list of ROMs here. Because if we filter these ROMs by Salomon here, we have like 53 files here. Almost all of them are basically sound stuff. See, by Chris Salomon. My guess is that he had some kind of generator that he wrote. Something like, you know, maybe taking mod files or something, XM mod, I don't know what. And generating the like equivalent for Vectrex, and so he just produced a whole bunch. And we've listened to a few of these on stream. There's like the Madonna one, but the one that was particularly interesting to me was where is it again? It's Doctor Who. Here it is. The Doctor Who theme. This one just sounded really bad, and I'll tell you why. But I think what I'll do is I'll actually demo it at that change list so we can hear how bad it sounded. Let's see here. Here, I'll check out this revision here. Oh yeah, so this change here, unrelated to sound, but basically it says add error handler unsupported for features not supported. It is sort of related to sound because I replaced an assert that I had here with an Hey, why did I put undefined here? Oh, that's funny. I added unsupported and then I used undefined. Okay, that was stupid. Anyway, I'll fix that. To remember. But anyway, let's focus on the audio here. So let's say we build this. Oh, and you know what? I'll stop my music here so it can actually hear what's going on. And actually, this is not the ROM we're interested in. Okay, so here's a demo of basically what it's been sounding like for the last couple streams. And with this specific ROM, you will hear that it's not great. Okay, so that was really awful, and I'm sorry to subject you to that, but let me just check out, yeah, so I'll just check out the latest because the fixes are in the next 2 change lists. And we'll just run this with exactly the same, whoops, just to close all windows. Now, same ROM, and now we're going to hear it with the latest changes, and you'll see that it you'll hear that it sounds a lot better. It's like way better. So yeah, basically, as you can hear, that's just a hell of a lot better. And it was kind of interesting figuring out what was going on. I guess actually it would have been interesting to see. Let me do this. Because I think it's really interesting to kind of show how I figured this out. Because, you know, if ever you're implementing audio and you want to see some stuff. So using the raw data output was actually key for me to figuring out what's going on. So I'm going to import the one that actually sounds good, and then I'll redo the other one and import its raw audio. So I'll just keep, this is the good version. I think I can even name it. We'll call it like good. And now let's go back and check out before we had that. So build again. This time we'll run. It'll sound awful. We won't play it for as long, just a little bit, because it'll be really obvious what's going on. Oh, and actually, yeah, I might actually redo this. So let me just pause for a second. I'm just going to close this. What we'll do is we'll bring up the debug window here, and I'm going to basically disable everything except for the noise, the tone channel for channel C, because as I know, that's actually where the problems, that's how I was able to isolate this problem. So that sounds bad, right? Okay, so we're just gonna kill that. We're gonna import the raw data. So now we only have the tone, which in the tone channel, the tone generator on one channel, what it means is we're supposed to only see square waves. So let's import that. It's 16-bit and it's one channel. And let's zoom in. So the problem starts here. So we don't really need to zoom in too much to actually see what's going on here. So remember that I was saying that it's a square channel, right? And already we can see that this is not quite square. So we've got, like, this is okay. This, you know, one period here should look, this is one period. The up and the down should be about the same size. So here we're fine. And here we're okay. But then what's this? What's this little bump right here? That's not good. And you'll see that that bump appears a lot. There's one here, there's one here, right? And that's definitely part of the problem. The other part of the problem, and we can see it later on, is when we look at these here, we have a short length up here and then a long here, a short and a long and a short and a long. And it kind of goes on like this for a while. So this is not normal. This is supposed to be a square wave generator, and we're not actually producing square waves. Now, this problem doesn't show up in most of the games that I've been testing, and it's showing up specifically in this ROM, and it seems to show up a lot actually in these generated ROMs for audio that Chris Salomon made. And what I realized was that unlike in normal games, these ROMs were basically calling set period multiple times, like almost, you know, at like every beat or something, even if the period wasn't changing. And you can kind of imagine, you know, if you've got this like generator, that's the kind of thing that generated code might look like, where it kind of does things that are redundant, but it doesn't really matter because, you know, there's definitely enough cycles to only play music and not have any graphics, so may as well, you know, just keep the generator simpler. So that was a big hint for me, and when I started looking at the code, let me go here, the first thing I realized was the timer class. So the timer is the thing that's used by the tone generator and also the noise generator. So the tone generator here has a timer in it, and it's a timer that's used. We take like the period time, we divide it by 2, and it's used to say how long are we up, how long are we down, how long are we up, how long are we down. And part of the thing is that if you set the period on the tone generator, like when you set the values, we call on period updated, and on period updated goes ahead and divides the time by 2 and sets this timer period to that, so that it can manage this up and down, right? But setting the period, at least the way I had it, would reset the internal position of the timer. And as it turns out, that's not actually how the hardware is supposed to work. I spoke to one of my friends who knows more about like how this hardware, how these, you know, these kinds of devices are built, and he said that sometimes it does reset, sometimes it doesn't. And if I recall, I think for the NES, it does actually reset the timer internally. And I had looked at my NES code and figured, oh, it must be the same, but it turns out it's not the same. And so what I do is I do something that the hardware probably doesn't do exactly, but it simulates it. When we set the period, I keep the relative position of where we were. So I compute a ratio, which, you know, as long as the period is not, the new period is not 0, or the old period, sorry, is not 0, I figure out what my current time divided by that period is. So that's just a ratio from 0 to 1. I set my new period, and then I set my time to be the new period times the ratio of where we were before. So that basically sets me at the relatively same position in the new period. So this was actually really important, and this actually fixed the problems of the spiky ones that we saw. These like here disappeared. The next change was here. So even though I had that, I had made another change which was related to kind of ducking out or not hearing the sound of the tone generator and the noise generator. No, sorry, actually it was for the tone generator. Not hearing it when its period value was set to 0. Okay? This actually was for a game. This was for Scramble, because I noticed in Scramble, when period was 0, we were producing a really high frequency sound anyways. Because what happens is that we basically ask, is a timer over? And if it is, we would go up and down, up and down. And so I had added this functionality that said, you know, we're enabled as long as the period is greater than 0, which is fine. But what wasn't fine was the fact that I was actually using it to determine whether or not to clock my timer internally. In other words, as soon as the period went to 0, it's as though the timer for the tone generator stopped advancing, which isn't actually correct. So for the Vectrex, the generators just basically never stop moving. They're always moving forward. So what I did now is I just removed the check in the clock here, and I use is enabled just as I was before, just to know whether or not we should even hear the tone generator. That's basically it. And those two changes was enough to make everything square. So if we check out the latest again, we're gonna do a little comparison with what it looks like on the latest. I'm gonna just capture the tone generator again on channel C and listen and take a look at it in Audacity. All right, I'm gonna just do this. There we go. And you can see here all the cool like UI stuff I've got going. Okay, that's enough. So that's when it sounds good, right? So let's import that. Whoops. It looks like I lost my... Why did it close my other one? That's weird. Yeah, very strange that it did that. Oh no, okay. I kept the old one. All right, so here you can see like the old with the weird values. The new, you can see, looks very nice and square. No more resets going on. And then later on, when we had the weirdly shaped short, long, short, long, short, long, which was related to the fact that we were stopping the advancing when the period was set to 0, now no longer happens. So now we have nice square looking waves all across. So the second one is the good one, and the first one is the bad one. So it really a huge difference. Let me see if I can. Yeah, actually they kind of line up, right? So this is the bad. We'll start here. And then this is the good. So like worlds apart, right? So really, really happy about this. After that, I just did a little bit of minor refactoring and stuff like that. So nothing really worth talking about. But yeah, basically we're in a place now where audio just sounds great, if I do say so myself. So like other examples of ROMs with music in it that sounds way better now. I think we had played this Madonna one last time. This one sounds a lot better. Sorry, when I click somewhere else, the frame rate drops for this. So I think it's pretty good. Pretty happy with that. And you know, of course, Scramble, which is one of the noisiest games, sounds pretty good as well. So yeah, that's pretty cool. All right, so that brings me to my list of things to do. So I mean, I would say I'm pretty much done. I just wanted to kind of clean up a couple of things related to audio before I finally merge in my branch here, because I've been working on this sound branch. You can see like it's been quite a lot of work. It's actually quite impressive. Look at this. We've got master over here, right? And then I just basically did all these commits. And when was that? That was like June 26th. So it's been like almost a month we've been working on this. Yeah, so just a boatload of changes. And you know, it's not that surprising, because honestly, audio is always a lot of work. Definitely took me a lot less time this time than when I was working on it on the NES. But to be fair, the NES was my first time implementing audio, so I had like no clue what I was doing, and I was able to scavenge some of that code for this emulator. So that's always good. So let's address some of this stuff. So I saw there was the undefined here. This was supposed to be unsupported. Not very major or anything, because honestly it doesn't change anything else. But yeah. So what I was thinking of doing, here, I'll just commit this little thing. What I wanted to do now in terms of cleanup is turn my PSG header into a pimple header, like I've done for so much of my code. Because I don't really like the fact that I've got all this stuff up here, and this stuff should just be private anyway. It's pretty much what I've been doing for most of my code. Like the CPU is implemented that way, you know, with a little pimple here. So I'm gonna just work on that. How did I do last time? Like this? Yeah. Yeah, so this will become PSG impl. So I'm going to do a rename here. Will not touch the via. Not touch this. And all of this looks good. PSG mode. So I'll start with that. Class PSG. Yeah, so all these functions here are going to have to forward. Nah, I might need more of the space than that. Doesn't really matter. Okay. So these move inside here. Oh yes, then I wrote all these classes here. Amplitude control, PSG channel, all of this has to move actually. And you know, I might move these into their own headers and stuff like that, but for now, that is my other option, of course. But eventually, like, I have thought about, you know, splitting up my CPPs and breaking them out, but I'm still kind of on the fence about how I want to organize my files. I don't really like having a whole bunch of files all over the place and not being clear on which ones are allowed to be included where. So that's why I still, you know, don't feel like settling on that just yet. Now, struct audio context. That was something I did not need anymore, it's true. What is that it doesn't like here? Cannot overload function distinguished by return type alone. Not sure what it's complaining about. Okay, so now I'm going to need to generate a whole bunch of functions here. Let me just see if this actually compiles as is. Ah, I see. To move that up. Okay, so that builds. So we're looking good here. Let's continue. We'll just do the same thing. Impl set BC1. Write DA. Yes, use of undefined PSG impl. All right, this is the part that kind of sucks. Not class, struct. Yeah. So there we have it. That worked. It's interestingly the via I did not implement it in the same way. And that's something, yeah, I gotta revisit this. I'm not sold yet on the whole pimple thing, but like I said, for now, it does allow me to keep things like now the CPU file, you know, the PSG is 700 lines of code, and there's lots of stuff in here. There's no doubt, but it isn't all in one place, and it should be easy to split out when I'm ready to. don't we try spike? So that still works. Why don't we try our other digitized audio, Moonlander. I like the music in that one. All right, that's pretty good. What was ROMs 2 again? No idea. Pretty awesome. Well, like that one. Love the music. So many now that I wonder what they sound like. Oh, Wormhole. This is a cool game. Okay, so no music while playing. This game is really fun, actually. But it's not easy to play with the keyboard. Alright, so this looks like it's working. I think I'm going to check this in as is. We'll worry about splitting it out at some other point. Pimpleize PSG. Oh yes, this one. This one should be easy. One thing I don't like right now is basically when I'm plotting the audio, is that if I pause, it continues to plot. You see? Until I unpause. Which is kind of garbage. But that's very easy to fix. All we gotta do is pass our time to frame update. Actually, this PSG impl, I should have made everything in line now that I think about it. It's usually how I do it. Anyway, it's okay. All right, and so now we have this. And now in the via frame update. So this guy also needs a frame time. Which means that in so that should do the trick. So now, I pause. Maybe I should not make it stop drawing. Let's do this. Maybe we'll split out. Yeah, let's do this. The drawing from the updating. And I'll need another one here. There we go. Works really well. Glad about that. And you know what? Why don't I just continue to flesh this out? Because frame time, the frame update thing is really a bit of a hack. I don't really like how I'm doing it, kind of propagating it down. There is some refactoring I've been thinking about doing. Maybe like right now I have this thing where the VIA owns the screen. It actually aggregates the screen in the PSG, but I don't really like that. And I was thinking of lifting all these types out, creating them in one place, and then connect and wiring them up together. And then this way I could explicitly call the frame update myself. But I'll talk about that in just a second. Frame update. Okay. Yeah, so architecturally there are some things I'm not super happy with, and I'd like to address them at some point. So let me just get this committed and I'll talk a little bit about that. I'll say we make sure to pass frame time to all frame update calls. Yeah, so what I was saying is there's a few things that bother me. So I'm generally happy with the architecture, but here's a few things. So I don't like that in my main, I have this class up here, which is called Vectrexy, and it is an iEngine client. The reason why I did this is because I wanted to split the idea of an engine, which I'm still happy with. This right here, I create an SDL engine, and that the engine knows about this thing called a client, and then it basically initializes and all that. And overall, that's okay. But there are some things that bother me. For example, I don't know if I'm thrilled at the idea of this, like the client here being the one that handles the open file dialog. And I was thinking about that, like, really that's not something that belongs here. That should just belong in the engine. So that's one thing. Like what I want is, or maybe it's okay that it's here, but what I want to do is I kind of want to maybe call this something else. And I want Vectrexy to really be a class that represents like the emulator core, you know? Basically it's the Vectrex Emulator. And in there we would have all the parts that make up the part that represents the hardware. So the memory bus, CPU and the VIA, the RAM, I mean, for the most part, almost everything here, but not the debugger. Probably not the overlays, because that's just a management thing at the higher level, and definitely not the sync protocol. So basically everything that's up here should belong to a separate class that just represents the emulator at the highest level. This object is the console, if you will. That is really the Vectrex. But what's missing in here are, I would like to also take out some of the things I've done. So the Via, it owns right now the screen and the PSG. And yeah, I don't feel like these things should be in here. Like the screen really is a separate component. The PSG really is a separate component. I would like to take these out and initialize the Via with pointers to these. You know, it's allowed to be, you know, it can be configured to like hooked up to the screen and the PSG, and that's fine. And but then these would be split out because these classes themselves are classes that have, for example, functions like frame update. And I would want this to be called on the outside rather than the way I'm doing it now, I think. And there's a couple of other little things like that. There's also that my update functions are a little bit confusing. Yeah, let's see here. Like the difference between update and frame update is not super clear. Oh, and a big one for me is the debugger. There's another architectural thing I'm not happy about. So here's the debugger, right? Overall, the debugger is fine. I'm happy with its utility and with its functionality. Just a couple things I'm not super thrilled about is, so see here you can see like I'm passing in the CPU and the Via. This guy does the thing of having pointers to the chips that it deals with, and that's great. What I don't like is right now the debugger is also the one that, you know, calls this execute instruction function, which in turn comes down here. And then if we pay attention to this call here, CPU execute instruction, and then underneath here Via update, this just feels like it doesn't belong in the debugger, you know? Really this should be happening. This should be outside of the debugger, part of the emulator core. And the debugger should just kind of be aware of, here, I just executed an instruction and, you know, go ahead and do your thing. Because I do need to do stuff, you know, pre and post instruction execution. So, I mean, part of this makes a lot of sense. And I do need to be able to kind of peek into the CPU and stuff like that from the debugger. But the fact that it's the one that calls execute instruction here, it just doesn't feel right. Oh yeah, what's this deal again? There's also some complication here related to CPU cycles. Ah yes, waiting for interrupts. Yeah, this stuff. I want to extract this, and part of that is why I want to do that is I want to be able to build and run my emulator without the debugger. So there has to be a way for me to extract this so that I can do this. I can run this without the debugger, and the debugger is just an optional component. Right now, it's a required component because it's the one that says, you know, time to execute an instruction. So I got to figure out how to do that. I'm not quite sure just yet how to do it. But yeah, so like weird things like that, right? Like the Via, because it's the one that owns the screen of the PSG, it forwards these frame update calls. You know, not the best. Yeah, there's a little bit of weirdness like that, but I mean it's not terrible. I guess the most egregious part for me is the debugger. That's probably the worst. The thing that bothers me the most. Yeah, this could totally be extracted. You know what? Just as a funny little test, let's see if I can do something here. Like, what if we didn't have this debugger here? And instead, I'm just going to copy some of this code this all I would need? No, this is not correct. What we would need, no, it's not as simple as that. I need to execute as many instructions as I have cycles to fill. Yeah, that's the part. Yeah, it's a bit more than just that part. It's true. So this is part of it. Yeah, see, this is why I don't like this code. I have this loop here. Execute instruction here. Execute as many instructions that can fit into this time slice, plus one more at most. See, this too is, you know, it's key to executing the emulator, whether I have a debugger or not. And right now, it's only in the debugger, at least part of it. Let's try to extract some of it just to see what that would look like. CPU cycles left. I'm just going to make this static for now. CPU cycles this frame, yes. I compute that up here. I'm just going to copy this. I have the frame time. Okay. I think that's, oh, and elapsed cycles. That I think is my effective cycles, yeah. Right? It is. Let's see if this works. So now I would have no debugger. Okay, it looks like it's working. Okay, so all this is working. And of course, I have no debugger anymore. So Control-C doesn't do anything. It's like this break into debugger. So that's it. You see, like this code here right now is spread out throughout the debugger. You know, we have a part of the outer loop here is happening up here. And there's all kinds of logic in here about, you know, modifying values based on whether we have breakpoints and stuff like that. And then we have this execute instruction, which has more debugger stuff in there. But in the middle of all that, we have the actual execute instruction here, followed by the update of the via here. So I need to think a little bit about, like, what's the right way to do this? I'm really not sure. Oh yes, instruction count. Yeah, that too. I don't even remember why I did this. If this thing returns 0, it's because we're waiting on an interrupt, but I want to keep updating my via as though at least some cycles elapsed. Why is that again? Oh, right, because, yeah, I remember now. This has something to do with, in here, we do something, we pull down, oh yeah, we've got like these, yeah, some of this logic here actually sets interrupts. Yeah, you see? That's it, IRQ enable and FIRQ enable. So that's that one here. And IRQ enable is get the interrupt flag value. There we go, CA1, shift, timer 2, timer 1. So some of these can only happen if we update, so that's why that we have to give it some X number of cycles. So it's kind of hacky. This seems to work. Yeah. Yeah, I'll put this on a little stash here. Call this no debugger. Okay, so I think what I'm going to do, okay, we're done with this, don't update plots. Yeah, volume control, which I can do later, and this one I'll probably never do. I'll put WAV file instead of raw file. In the end, the raw file worked just fine. I think I'm just going to move this down, say. So with all that, I think we are ready to do a merge of sound into master. And what that means is that the official builds on GitHub for Windows 32-bit, 64-bit, and Linux should include sound. I'd be interested to actually know if this works on Linux. I have not tried it at all, of course. So it would be worth seeing if that actually works. So let's check out master here. Merge in sound. Create a merge commit. And let's push this. There we go. And I will delete these branches. Remote. local. All right, and this means, let me see. Yeah, so you can see here, basically it says that the build here is pending. I don't know if the Travis does the same thing. Maybe at some point. But yeah, at some point, hopefully this passes and we'll have new binaries here. So those of you interested in trying Vectrex, you can actually let me know how it sounds on your machines. Be interested to know, actually. Okay, let's keep this over here. So what do I work on next? I don't know. Oh yeah, there's some more stuff I'm not happy about. Reset overlay being this. There's a couple of functions that are global that just kind of suck. Here, my engine client header, we have these global functions: set focus main window, set focus console, and reset overlay. This one is especially egregious. I don't like this at all. Yeah, definitely some refactoring is in order. Yeah, it might be confusing to have a Vectrex class and a Vectrexy class. That's not a good idea. Yeah, maybe I just don't need a class called Vectrexy. Figure out a way to extract the CPU via update loop out of debugger so that it can be executed without debugger. Yeah, this is something like the GL render is kind of weird because it's the only thing I have that isn't a class, but really should be. There's just so much of it that's global variables for like no reason. And it's all because it's just not a class. I don't know why I did this. I made this a namespace with a bunch of functions, and then I have all these global variables, and it's just completely weird and doesn't fit the model whatsoever of the rest of the code. And it would be totally trivial to just turn it into a class, so I will. Oh yeah, so move screen and PSG out of via and just pass them in. Just okay. Debugger plus sync protocol, separate path where these are initialized used. I'm not sure how I'm going to do this yet, but I need to figure this out. And then finally, I think the big one is going to be to figure out a way to actually break out these files into directories and or separate projects. Maybe using CMake for that. Like something like, you know, something. Whatever, I'll figure it out next time at a later point. Yeah, it's basically something like STL engine, GL render, and then all the mGUI stuff. Although the mGUI stuff is going to be hard because it's actually referenced within the core. Yeah, that's kind of shitty. And then there's the whole question of whether the MU core itself should be split up, but I don't think so. Maybe, like I was saying, just into directories or something to help a little bit with understanding which files go together. Curious about the size of these files. Yeah, CPU is definitely large. Looks like, yeah, GL render would be a good one too. Some of these are necessarily large though. I don't know if CPU will ever get smaller. It's all about how it implements all the functions of the CPU are in here. Okay, well, I mean, yeah, there's stuff to do, definitely. But I'm not going to get started on that. With the time remaining, I think I'll just see if I can figure this point out. I don't think I will, but this is the one thing that bothers me, is that Spike itself doesn't work. We can't see the gaps in the platforms. And that's something that really sucks. Oh, and there was one other thing, but not a refactor. Look into using custom BIOS that skips intro. So this is interesting. I'm gonna have to, like, when I say look into, I mean like see if it's okay for me to use. I noticed there's this other emulator, and actually it's one of the best emulators that I've tried so far. So VDay is great, but ParaJVE, which is more like a standard emulator, not like a environment to build things, I find this emulator to be quite good. It's another Java one, but what I noticed inside it is that it has, where is it? ROMs system. Yeah, these here. So it's basically its boot. Let's see, like I have this BIOS ROM.bin here. And he's got, the author here has provided 3 different versions: the fast boot, the skip boot, and the system. I don't really know why one is called fast and one's called skip. We can give them a whirl. So let's say I rename my BIOS ROM. And we'll copy fastboot over. So this is fastboot. So let's just see what happens. From what I've seen, at least in his emulator, it skips that whole Vectrex intro and goes straight to the game, which is really nice. Would have saved me a lot of time, actually. So you see, we actually do see the Vectrex logo a little bit. So that's the fast boot. Okay, so the skip boot just, I think we just don't see the Vectrex logo. This is skip boot. What was that during the beginning there? I guess as my emulator warms up, there's like a few frames of hitchy music there. Say scramble. Yeah, that's pretty sweet. I gotta say, not having to wait at all. We don't even hear the intro music. It just goes straight into the game. So I guess that's it. That's really the big difference. We don't even get the intro music. That is really nice. Say skip. This was fast. So fast here we should get intro music. Let's say I grab. Yeah. Scramble. It would be nice to have support for those, wouldn't it? So I'm gonna write to this author and ask if it's okay for me to use these ones here. I don't know if these are like, you know, modified by the author or whether, you know, these are kind of available to people. That's what I got to find out. Yeah, because I see even V-Day has the same thing. He's got fast boot here. Does he have skip boot? Actually, fast boot 8192 7 ADB M2 system. He's got a whole bunch of different ones here. So you got the listing for the fast boot. Okay. I'll leave this in here for now, because at least for now. Oh no, that's not the one I wanted. I wanted to skip. So now we have that. Let's go to Spike. So you see we're drawing all these lines, but some of these are not supposed to be drawn, and I'm pretty sure this is related to an optimization I had made a long time ago, and I don't know how easy it was. I had it in a state at one point where I could toggle the optimization on or off. So it's in the screen code here. So let's go over this a bit. Basically, yeah, it's here. I have this whole thing where I'm tracking the position that you're currently at on the screen, and I'm figuring based on velocity, the velocity we've computed, what's the direction you're supposed to be going in. Which could be 0. I wonder if it's related to that, actually, keeping in mind that it could be 0. And then what we do is, what? Oh yeah, look at this. I have some debug code that's managed to survive this long. That's fascinating. Okay, and then move beam while ramp is on or move beam while ramp is on or on its way down. So here we compute a new velocity and move our position. And I say we might draw even when integrators are disabled, drawing dots, okay. And then here, if we've determined that drawing is enabled, like by the hardware settings here, if I was drawing last frame, so if drawing was enabled last frame, and the magnitude of our last direction is greater than 0, so we were moving last frame, okay, so that's where the 0 part comes in. And our last direction is still the same as the current direction. Oh, you know what? I think I see the bug. Is that the bug? Oh, and not, okay, and if we're not empty. Okay, so if any of these things are false, we just immediately place back. Maybe this is fine. Because basically what this condition is supposed to be is, do we modify, like, because the idea is that as a line is being drawn, we're doing the cycle by cycle. Yeah, this actually is called per cycle. And we end up adding many dots, like many line segments for that line that's going straight. And so to optimize rendering and to make this array not take up so much memory for no reason, we basically coalesce. We figure out if we can merge lines over time. And that's what I'm doing here. It's kind of like bool coalesce line, and that's what this condition really means. And here we're saying if we can coalesce the line, then just do this. I was looking before at this condition here. But yeah, I guess that's okay. And then afterwards, we always update this and this here. See now, if we don't do the coalesce lines, let's see if that's something we can test. We still have the bug. So that's sort of good news, actually, because it means it's not in there, the bug. That's good, actually. Yeah, interesting. Right. What's funny is that this used to work. I wonder what changed. Let me look at the history of this guy. Do I have... Fixed line coalescing bug when zeroing beam. This is one of the last changes I made related to this. That's where I added this debug stuff and I forgot to remove it, interestingly. Yeah, so here is where I was checking if the magnitude of the last direction is greater than 0. But I think the real fix was this last drawing enabled here. Let me see. Well, actually, we know that doesn't make any difference because I'm not even checking that. Yeah. None of this seems to matter because I'm not even coalescing. If drawing is enabled now, I just always in place back. So this is where I actually did the coalescing thing. Yeah, you see? What I used to just do was in place back, which is now pretty much what we've got when we make this false. Nice and simple. Should learn to spell. I wonder if it's related to this. It's possible that it's related to these delays. Let me see. That's actually possible. We'll play with these ramp up, ramp down delays. Screen. No. Okay, so it's not that. That's weird. Why did I make this velocity y a delayed value store if I don't even make use of it that way? That's just weird. I guess I thought I might make it that. Oh yeah, and this code used to live in the VIA. Don't know if it broke back when this happened. I wish I could understand what's going on here. I wonder if the problem is actually in rendering. It's going to be really hard to know. Create line and point vertex arrays. Not sure. Maybe this never worked. Now I'm starting to doubt myself. Maybe I didn't have this game working correctly. I thought I did, but I'm not sure anymore. I think what I am remembering is maybe I'm misremembering this. I think it was this last drawing enabled thing that I remember fixing, and it made Spike look really weird when I didn't have that. Oh, and I guess I would need to put this back to on for this to make any difference, obviously. Yeah, that's it. I think that's it. When I fixed this, I thought it looked right, but I didn't know that they were missing, that I wasn't doing the right thing. Yeah. Move beam while ramp is on or on its way down. realize is I technically don't need last direction to be updated here. Just like I do this here. This would have to be done up here. It's more clear and I get rid of that variable, so that's actually a good change. State machine update, current direction. This could actually be computed down here. Oh, hey, thanks for the follow. Code Toad. Hey, thanks, man. Appreciate it. Wait. Ah, okay. This is what I was looking for. I was like, where is the velocity set? Okay, it's through these functions. Set integrator x, set integrator y. And these are called by the via on the screen upon doing writes to specific addresses. Oh, hey, cool. So you saw me on Ferris's channel. So it sounds like you've written your own emulators then. I totally agree. It's super fun. Oh, chip 8's a good start, man. It's a great start. But yeah, it is really, really interesting. I used to code like pretty much only games. I was, so into making games, and I do work in the industry, so that's sort of the point. But eventually, I tried my hand at writing a NES emulator, and honestly, it's hard for me to go back. After that, I didn't really do much, and then I decided to write this emulator, and I'm already thinking like, what's the next system I want to emulate? Just because it's just really that much fun, I wonder if right update integrators. Try something. Oh wow. Okay. Right. Yeah, I'm not saying I don't enjoy it. I still do love making games, and that's why I still work in that. But there's just it's a totally different challenge writing emulators. I feel like it's like writing games, right? There's a whole visual and audio aspect to it. There's a lot of overlap, right? Like, doing like in this one, I've written a bunch of OpenGL and shaders, and writing to the sound card and polling input and joystick support, all these things that you do in games. But instead of writing like a game core with all that, you have to figure out how to emulate hardware, and that's just a whole other thing, right? And if you're into that, definitely I am. It's just really, really interesting. A lot of like, there's this whole thing about like, because hardware, when you look at it, it's pretty simple. You know what I mean? Like a lot of the hardware, especially from this era, does simple things on its own, but it's the combination of everything. And it's kind of like, where do you draw that line? Like, where is your level of abstraction going to be? How do you model things? Some really accurate emulators go down to the every little chip to every little cycle, whereas the kind of emulator I'm writing is a bit more higher level than that, or a lot more higher level, and just kind of simulating to to a various degree of authenticity, right? Like, it doesn't have to be perfect. It just has to be good enough to give you the impression that you're playing on the old hardware, and fast enough as well. So it's a really interesting kind of thing to figure out. All right. It's actually not this one. It's this one I wanted to see. It's port B. Why is it again that we had to do this? It's port B, update integrators. Let me see. Now we have nothing. Because we read port B and we also read from port A. Okay, fair enough. It's not what I was thinking. This is not correct, but I just want to see. Yeah. See how like minute changes break everything. They seem like innocuous, but they're so important. When I'm just wondering if it's possible that we are sending a value, an integrator value, and then I don't know. How can I figure this out? Maybe I can do this by seeing what is being sent through the BIOS routines for drawing the floor. So, you know, as a point of comparison, let me see if I can run this in try para. Let's see if this works. Spike. So this is that other emulator I was talking about that I find really nice. Although I think my emulation of the digital samples is better, but I like, there's a few things I really like. I love that you can see the kind of screen behind here, the kind of curving of the screen. It's kind of cool. But yeah, so this is what we're looking for. You see how like the platforms have these gaps? This is what's missing in my emulator. There's some things I'm doing better too, like this ladder here, my lines line up better. Yeah, in case you were wondering, Koto, this is what's missing for me. You know? Let's try and do like a little side by side just to kind of see what it looks like. So you see like my ladder looks a bit more like a ladder. There's differences there. Although I have some like little lines jutting out here which are not apparent here. So, you know, maybe this is more correct. Not sure. But obviously lots of similarity. Yeah. But I'm missing this, you know? So because basically without the gaps, the game is impossible for me to play. See? I fall because I don't know where the gaps are. Because here the game is actually playable. It's a weird game. Enteramano. How can I be good in C++ for game development? I use Unity, but I want to develop my C++ skills. When I search tutorial, I can't find enough tutors, and tutors don't explain enough for me. I am always confused. And Code is asking about bindings for C++. Start with basic OOP. I would recommend getting a good book, especially if you're just starting. So I've been asked this question before. You know, how do I learn C++? What's the best way to do it? There is an excellent post about it on Stack Overflow. This one here. The definitive C++ book guide and list. And basically it's here. So this, I really like this post. I've shared this a few times before. And what's cool about it is that it breaks it down into different sections. So you have like introductory, no previous programming experience. So it gives 2 books here. One of them is actually by Bjarne Stroustrup, the actual inventor of C++. So, but yeah, you got a couple books here. I've heard a lot of good things about C++ Primer. And then if you have previous programming experience, which it sounds like you do, I don't know how experienced you are in C# and in Unity, but if you're pretty well versed, you might want to look at books inside here. But yeah, somewhere in this area if you're just starting out, because after that it gets into more advanced stuff. You know, you got the best practices books. These are well-known and excellent books by Scott Myers, and then you've got, you know, intermediate books, and obviously then you go into more advanced books. So yeah. Yeah, there's a bunch here. It's interesting too. They have a bunch of like classics or older books that are great, but have not been updated for the latest standards. Yeah, here, no problem. I'll send you a link. I'll paste that right here. So, I mean, you know, disclaimer, I have not read either of these here. A Tour of C++, I've kind of flipped through it. I have not read Accelerated, so I can't, you know, for myself say these ones are particularly good. I've read Effective and Effective Modern, some of Effective STL, so that's more into best practices. Not this one. I've read Exceptional C++. C++ Coding Standards I've read. This one I flipped through. I've read this one a few times. Modern C++ Design. This definitely you want to be a bit more advanced before you read this, as the heading says. I've read this one, Template Metaprogramming. So a lot of books. And honestly, for me, like, the books were really important to cement the learning. Yes, you can do online tutorials and you can learn by doing, and you should be programming and making projects. But there's just so many important fundamentals that you got to get down, I think, before you really, you know, really become you know, strong at the language. You can get by, but if you really want to be able to kind of master it and get far with it, personally, I think books are the best way to go. Yeah, no problem. So yeah, I do not know what is going on. This is kind of difficult to debug. That's the thing about Vectrex, is that it's just one beam that's moving around. I don't know exactly how I'm going to figure this part out. Kotoad says, I personally recommend learning OpenGL before using a library that utilizes it and abstracts it away. It will be a little more difficult, but then you move to something like SFML or libgdx. If you ever do any Java, you'll understand what is happening underneath. That is true. Hey, Peas and Rice, long time no see. Are the gaps in the platforms only not showing in certain areas? So it's not showing at all. And you know what we see here, these are not real gaps. This is just because the game has decided, you know, that the cutoff has occurred for this platform, and at least that's what I think. Yeah, you kind of see like when you don't see. Oh, I made a little guess. Here it's going to suddenly appear next to it. It's true that it kind of goes for a while before it appears. Let me see if that's what happens. It's true that that's not really what happens in this game here. Yeah, it's very different behavior. Like it's weird how up here there's no lines here until this thing is completely off screen, right? I mean, boom, then it just suddenly drew here. Yeah, exactly, like you said, like less pop. Oh, that's interesting. That's very interesting, actually. Makes me wonder. Yeah, that's a good point about clipping. Bama the Sheriff. I'm sorry, I'm totally butchering your name. I'll call you Bama. Bama says that maybe the lines in the list are to render are getting clipped. That is possible. So that's, you know, we're talking about the edges, which there seems to be a difference in sometimes in the way the edges are clipped. Like here, right here, I suspect there should be lines. Brahim? But then sometimes it's okay. Like over here, we see we're not getting the clipping effect. And then here we see what happened here. Where are the lines that are supposed to be on the side here? And then suddenly, boom, then this whole platform appears. Whereas here, it doesn't seem to do the same, right? You see there, it's kind of a continuous stream of lines. Otherwise, there are no lines that will ever be drawn. So definitely something off here. And so it's either the lines, like either my line draw, there's two places where it can go wrong. There's the screen where I produce the lines that will be sent to the renderer, and then there's the actual rendering of the lines. but and what, so that's, there's something weird definitely on the edge, which may be related. And then there's the whole point that, you know, we get all lines being rendered here, and we don't see the places that should have gaps. So that's the crux of this bug here. And it's really annoying because I keep falling because I don't know where to be. See, like it just disappeared. The whole platform disappeared. It's super interesting. Let me think about that for a second. Yeah, it's possible that that it's at the rendering, but see, that would explain for the edges. I don't see how it could be, how it would explain the fact that I have actual lines here. And you know, like, apart from this game, lines are being rendered correctly pretty much in every other game I've played, to my knowledge. This one must have some weird rendering routines. It's not always ones on the sides though, right? That's like, we're noticing, like Peas and Rice pointed out, that there's something odd on the sides. Sure, but you know, the platform is in the middle. Yeah, I'm not sure. Yeah, I don't know. Kotoda is saying that for games, C++ is better. Because the question is, what's better to learn first, Java or C++? So I mean, I learned C and C++ before I learned the higher level languages like C# and Java and Python. So it's, you know, it's hard for me to know exactly what's the right path, but definitely, you know, Java is easier, right? Kotoda is pointing out about, is saying that there are pointers in C++, which can be harder to understand. It's true. It's true. I mean, it's a hard language to learn in its entirety. There is a subset of it that's not so bad, especially with modern C++, but there are things about the language, because it's really old, right? It's like C++ is, it's like super old now, and there are things, part of its legacy of course is C, and a lot of the legacy is still present. All the stuff about how to manage your files, your CPP and your header files, managing dependencies is really annoying. All of those things are just way simpler in languages like Java or C#. So sometimes, you know, if you want to just kind of get into this language, it might be easier to go into Java or to C#, learn all the rules and like get comfortable with the programming paradigms, and then when you move to C++, maybe the incremental step into C++ will be easier. So Brahim is asking, could it be that there is a certain amount of time to render all? Some lines get cut because of timing. Oh, thanks. If you'll follow my work, that's cool. Yeah, so lines getting cut. So one thing I'm wondering about is it very well could just be that the hardware is clipping and I need to do my own clipping. That's very possible. What I mean is that what I do here is I take this big vector of lines that got passed in. Oh, I usually stream on Tuesdays and Thursdays, starting at 9 p.m. Eastern. I think I wrote that in on my profile page in the bottom section somewhere. But anyway, yeah, Tuesdays and Thursdays, 9 p.m. Eastern. Like right now for me, it's almost midnight, so it's been like almost 3 hours or something. But yeah. So yeah, like you see, like line is basically just 2 points and a brightness. And what I have is this function. The main one that I use is, actually it's this one here, create quad vertex array. But either one, that doesn't make a difference. This is the easier one to understand because I can toggle on or off the thick baselines, but I get the same bug whether that's true or not. I'll show you here. I go into GL render and I turn off thick baselines. We still have the bug is still apparent. And this is the simpler path to understand. Because the other one, I'm building quads, right? Not that it's much harder. And then here I kind of have to deduce whether or not I'm drawing points or lines. Because that's the thing with the Vectrex is that, you have this beam that you just move around. It's not raster at all, right? It's literally you control this beam. It's super interesting in terms of like hardware and how you have to write games for it. But the point is, if you want to make like stars, like a star field or something, like there are games that have that, you have to move the beam, like turn it off, move it, turn it on for a few cycles, turn it off, then move it, turn it on for a few cycles. So that's how you make like dots. Otherwise, you turn it on and then you move it and then turn it off to make lines. It's literally what the Vectrex does. And from a perspective, like from the programming perspective, from making an emulator, you have to figure it out. Is it a dot or a line? So that's what I do here. I have this kind of, I check to see if the 2 points are, if the beginning and end points are nearly the same, then I consider it a point and I add it to this points array. Otherwise, I consider it a line and I add it to the line array. And yeah, and I just basically add these lines, which are, what is this again? I haven't looked this code. So it's a vector of vertex data, which is a GLM vec2 with a brightness value. Yeah. And then I take these two things and I give them to my draw vector pass here. And you see I pass in GL lines and GL points because that's precisely what I'm using in this case. Otherwise I use GL triangles for my quads. And then in here, so what was this again? This was, the first one was, it's going to be lines. So yeah, so I have basically two calls, one for lines, one for points. And then here, I mean, there's nothing magical here. I just set the mode. So it'll be GL lines, let's say. So where's my mode here? GL draw arrays. I say, here we go. A bunch of lines that I've updated, that I've uploaded, sorry, to the GPU, which is over here. The vertices are here and the brightness values are here. And then I do GL draw arrays, lines, all the vertices, like the size of the vertex here. And then that's it, then it draws. And then basically this is using my draw vectors vertex and fragment shader. So here's the vert and here's the frag. Nothing special in here. And then the fragment shader. I mean, it's as simple as it gets, right? And like I said, you know, this has been working for pretty much every other game. So there's something else. It could be, what could it be? No, I'm not sure. You could try not draw anything on the half right part of the screen and see if this missing lines persist. You could try to not draw anything on the half right part of the screen. I'm not sure I understand what you mean by that. Like, what's the strategy there? Try not to draw anything on the half right part of the screen and see if this missing lines persist. So what I wanted to say before, I forgot to say this, is, so I'm sending all these lines, right? And probably what we're seeing is, at least on the right side, that lines are getting clipped because I'm sending lines that actually go off screen. And I don't remember if OpenGL, I think, doesn't it like by default clip geometry? And what I mean, does it actually clip, or does it not draw the line at all if it goes off screen? Okay, so it could be specific to that game. In real Vectrex, how many lines at max? So, you know, how many lines, it's very difficult to say. You know, it's kind of weird, the Vectrex. Like, if you move the beam at its fastest rate, you can draw quite a lot of lines, but the lines won't be as bright. If you draw it slowly, you'll be able to draw less lines, but they'll be brighter. And you know, there's also some careful stuff there where you want to tell it to start drawing, and then it can take some cycles. And in those cycles, while the beam is moving, you can actually do other things. Now, for the most part, games don't really do that. Like, there's a BIOS that gives a bunch of really useful routines for drawing vectors, and you just kind of give it a vector list and it just draws them. And when it does that, you can't really do anything else. But there are some games that do custom rendering. It's possible that Spike is one of them, which is maybe why we're getting in trouble here. Another one is there's this kind of Pac-Man clone that just has a ton of lines on screen. I'll actually show it to you just because it's kind of interesting to see. That also uses its own custom routine for drawing lines. What's it called again? It's Clean Sweep? Yeah, Clean Sweep. See, like this game just draws a lot of lines, way more than usual, you know? So Koto says he concurs with what? If coordinates are larger than half the screen with don't draw. Okay, so is this just to see, we just want to see if it's a real clipping problem at the OpenGL, like in OpenGL? Is that what we're trying to determine there? Like, if we don't draw to the edge, then we'll know whether it's hardware clipping or whatever that's causing the problem. Is that what we're hoping to determine? We could do that. Do it here, or we could do it when we transform into lines, I suppose. I don't know what's simpler. Yeah, maybe when we transform in the renderer, it's easier. Okay, so let's say in here, if p0.x is greater than, now what is this again? I think I have it in the screen. Oh, yeah, it's here. In terms of memory, there should be a maximum number of points and lines to be drawn. Are you talking about, like, what are we talking about when we say memory? Okay, so if this is greater than that, or p1.x is greater. Actually, is that what we want to do? Do we? Yeah, I'm not sure this is going to give us what we want. Yeah, I'm not sure what you mean by talking about memory, but I mean, we have enough. Like the game, the emulator runs at a really high frame rate, and we have no problem sending these to the shaders. We're not running out of memory or anything. I don't know if that's what you meant, but yeah, I'm just thinking about this, like, if we do this, we still may see like a kind of a clipping occurring, because if one end, like if the P0 end, like if we have a line from P0 to P1, and these are not ordered, by the way, they can be in, one can be on the left or to the right, let's say, right? If either one of these is greater than half, then the whole line won't be drawn. So that's probably not going to give us what we want to see. This will actually just not render the line at all. And it doesn't seem to be doing anything. Did I actually build this? I did build. Oh, I know why. Yes, but the fact that the original Vectrex has limitations is respected by the emulator, sure. Kotoed. I mean, what I was wondering is that if one of the points was off the screen, if OpenGL was clipping it, right? Yes, I'm wondering the same thing for sure. I'm not sure my test here is actually going to help figure that out, right? Because if I'm basically going to just remove an entire line once it passes the midpoint of the screen. I would need to do clipping. Basically, that's what this is, right? What I need to be doing in here is knowing what the edge of the line is. If I have a line that goes outside, clip it to the edge. And I think that will solve the problem. So let's see here. GL render, remove this. we're making it in here. Oh, and yes, okay, the coordinate space is not, okay, it's not from 0 to the width. That's why it's not working. Yeah, so Brahim, just to answer what you're saying that about the original Vectrex having limitations. So the emulator core is emulating a real Vectrex, right? It's like trying, the limitations are inherent. All it's trying to do is follow to cycle accuracy, how things can move. Yeah, exactly, Kotod. It's not going to help. So basically, when we advance the emulator, we're doing it based on time. I know exactly how many cycles the CPU can run at per second, how quickly the VIA chip can run per second, and basically everything is on this time-based cycle timer thing. So if you're really curious about that, it's in the code right now is in the debugger. Not that it's a good place. I actually spoke about this earlier on stream, but if you look up here, where is it? It's over here. Yeah. This is like how I do timing. So like a lot of games, this is not like a frame-based thing. I don't try to stay at 60 frames per second or anything. What I do is that every frame we compute the delta time from last frame, and that delta time is passed in as the delta time for the next frame. This is very common in games. It's what we call making your game time-based. So we're trying to run as quickly as possible at the highest frame rate possible, and your delta time is going to be whatever it's supposed to be based on your current speed. And what I do is I over here I compute the CPU frequency, which is actually 1.5 megahertz. And knowing how many cycles per second the CPU is supposed to run, I multiply this by the frame time, and I get the CPU cycles I have to execute this frame. Now this actually is a floating point value, which may seem a bit weird, but that's because we don't want to truncate and like miss out and lose the error. So we want to kind of keep the error, and so that you'll see. So let's say, imagine we get some not like a rational value here, like something with decimals, and then what we do is we say execute as many instructions that can fit in this time slice, plus one more at most. So I have the CPU cycles left, which is also a double, and we plus equals to this. Now the plus equals may seem strange, but this is the part about the error. This starts off as 0. So let's say CPU cycles this frame is 50 or 50.5. So while it's greater than 0, we go and we actually execute instructions, and we get back how many cycles have actually elapsed, and we subtract that from the number of CPU cycles that are left. So then this here eventually will go below 0. It'll be like minus 0.5 when we're finally finished executing our 50.5. Now this runs, right? And so we have executed now the CPU for as many cycles as it should be executing, with at most 1. But that at most 1 will get corrected by the fact that the next time around, CPU cycles has some negative value in it, like minus 0.5, and we need to add to it how many for this frame. So you can see that over time, it's like basically the extra instruction we might slip in one frame, the next frame we might have one less kind of thing. So it's just basically quantizing the instructions over the non-integer delta times. Then we take those cycles here, and we execute instructions. And executing instructions is basically executing the CPU, which then returns how many cycles have elapsed from that executing of the current instruction of the CPU. And then we feed that into the VIA. And the VIA is the chip that drives the rendering. So then that too, again, we get how many cycles it's supposed to advance, and then that advances all the things that are related to the peripherals, including the integrators for moving the beam, and then that is the logic that's basically in the screen. So everything is down to the cycle, and everything we do is works that way. Like here in the screen update, you see we have the number of cycles here. We use that to basically do our updating of certain variables, and ultimately this is where we do our drawing. So those cycles are you can see here, are used to determine what our delta movement for our beam is going to be. It's because the beam is basically, this math here is how much position you move per cycle. And in fact, when we call this function, we actually only pass it one cycle at a time on purpose. I wrote cycles here, but really for this to work, it's more like clock it per cycle. So n_screen.update. We say cycles here, but this is in a loop where cycles is always 1. So we basically call this function one cycle at a time, and in here we basically move our position forward one cycle at a time. So yeah, this is a good model for how to do things, you know. So peas and rice. Can you easily get the coordinates of the vectors being displayed on screen? I'm curious where the vectors start and end. It's so funny you should say that. Because I was thinking about that before, and I was thinking that it might be useful I was thinking it might be useful to color the segments differently, like have maybe just cycle through a bunch of colors, because right now actually it's black and white, you know. Don't be fooled by the overlay, right? This overlay here is just, there you go, now it's black and white. So actually, yeah, that might be a good idea, is to kind of color each segment, just kind of cycle through a bunch of colors, and then actually we would see where the segments begin and end, type of thing, you know? And maybe even do something like either choose, like I can even do something like where I do the bright version of a color to the dark version, and we can really see the start to end for each segment. So Brian says, I did not realize emulation was done that way. I mean, it's not always done that way. Some emulators are written a little bit differently. But you know what? There's something, by describing this to you, I was thinking about something, and I was thinking about, could it be, I'm thinking about how, let me just try something. I'm not gonna explain anything. I'm just thinking it's got maybe something to do with really high frame rates, and maybe detecting changes. Could that be? It wouldn't be here. Yeah, maybe. So enabling VSync here will slow down the emulator to around 60 frames per second. And I'm just curious to see if that has any effect. Nope. Well, at least not like, at least this is not okay. In fact, you see it's more like 30 frames per second. I had noticed this, and even lower. I'm not quite sure. There's something weird with the VSync, and I never really investigated. It's on like my to-do list of things to look at. But maybe it's something like that, you know. Maybe there's a like we're calling this, maybe we're building a list of lines that I'm not sure. So not sure. I need to think about it. And well, you know, it is Tuesday, so in a couple of technically it's Wednesday, but on Thursday night, 9 p.m. Eastern time, we'll get back into this. Length list can be used to modulate the red intensity. For example, early segment will be red dark and the last one will be very red. Yeah, no, I understand. The length of the list can be used, yes. Yes, I see what you mean. Like kind of like your position in the list can be used to modulate the colors. Sure, that's another way to do it. I was more like thinking like each line segment would have its own color. We might cycle through, let's say, yellow, blue, and red, or something like that, right? So it's just so that and then it'll cycle again, because you know most lines are not right next to each other; they kind of spread out, so we would be able to see them. And then for a given line, I'm laughing at peas and rice. I'm going to lose sleep over this. Anyways, for a given line, like we could say like, you know, one end is bright and one end is dark, so we can kind of see where the start and end were, so we can kind of get a feel for the direction of the lines. So maybe I'll do something like that. I don't know. We'll see. I'd have to modify my rendering code, so I don't really support passing in colors right now. I just pass in positions and a brightness value, so I'd have to add passing in colors. Not that it's hard or anything, but so maybe that'll help us debug the problem. Apart from that, yeah, I don't know. I have to think a little bit about it. It's really the only game. Oh, it's lunch. Lunch Wednesday in Singapore there. Nice. Yeah, so this is it. This is a game that's causing me some pain, and we'll try and figure it out. Yeah, so I never actually finished this part here, but yeah, I think maybe some basic clipping here. If we have to clip it ourselves, I don't know if we have to, but maybe we need to clip it ourselves. Thanks, Code appreciate it. All right, guys. So let me sign off here and see you guys. Hey, thanks, peas and rice. And I'll see you guys in a couple nights, hopefully.